example 10, find the derivative of f of x equals tangent x. To do this, we first want to write this. We're actually proving the statement in this theorem below. We're going to write this as sine x over cosine x. And treating that as a quotient rule, u prime is cosine x, v prime is minus sine x. Treating that as a quotient rule, we have got that f prime of x equals low d high, so cosine x times cosine x minus high d low, sine x times negative sine x over low cosine squared x. Well, this is cosine squared x plus sine squared x over cosine squared x. Well, sine squared plus cosine squared is 1. That's the Pythagorean identity. So this means this is 1 over cosine squared x, which is secant squared x, which is the first derivative in that list. So that is actually a proof of this using other derivatives. Often turns out like that. Example 11 says find the equation of the line tangent to f of x equals cotangent x at x equals pi fourths. Now if you notice, we have actually the derivative of cotangent listed. All right, so we want to find the slope at the point, let's go leave that as x first, of cotangent x. Alright, well, the derivative of cotangent is minus cosecant squared x. Now, evaluating that at pi over 4, we actually get minus 2. So that is our slope. It's the slope of our tangent line. Now we'll go to point slope form. Y minus y1 equals our slope. Let's actually write it like this. F of a equals f prime at a times x minus a. That is the calculus version of the point slope form. Oh, we actually need a point here. So this is our a value. So f of a is cotangent of pi fourths, which is 1. So we have y minus 1 equals minus 2 times x minus pi over 4. Distributing, we have y minus 1 equals minus 2x plus pi over 2. And adding 1, we find the equation of this line is minus 2x plus pi over 2 plus 1. I'm going to leave that as an exact statement. All right, number 12. Find the derivative of f of x equals cosecant x plus x tan x, or tangent x. First one, derivative of cosecant. Not too bad since we've already got that written down as our theorem. Hopefully you wrote that down. That'll be minus cosecant x cotangent x. That's the derivative of this. Now for x tan x, that is a product rule. Okay, so we'll take the derivative of x, which is 1 times tangent x, plus x times the derivative of tangent, which was secant squared x.